For the chromatography part of the experiment, I have 4 what we call chambers. This is going to contain the solvent that we can develop our chromatogram in. So the lid here is just a watch glass. You want to make sure there has some cover associated with it. You don't want to just leave it open to the atmosphere, because the solvent will evaporate and then you'll have no solvent left to do the experiment in, or if you change the concentrations of the solvent, that can also affect the outcome of the experiment. So I've labeled these jars as 1, 2, 3, and 4, and I'm trying different solvent systems, and there's not really an equation you can plug into to figure out what's going to be the best solvent system. It's not unusual for a person, if they're trying to figure out how pure something is, which chromatography is certainly used for, they may have 20 or 30 chambers that they will run simultaneously and see which one's going to give them the best separation. And that's really what we're trying to do in this thin layer chromatography. We're first trying to see how many different components we can isolate in the spinach by the extraction method we just used. And can we, some solvents, maybe I should say it this way, some solvents may give more components in the mixture than other solvents. And so we want to kind of see, out of these 4, is there one that is significantly better than the others, that if we were to do this on a large scale, that we can separate all those colored pigments from each other. And it may be possible also that we're also going to use UV light once the chromatography sheets are developed. We may actually see something that isn't visible to the eye, but may be visible under UV light. So the first chamber that we have, I'm going to use petroleum ether and acetone in a 70-30 mixture. So I'll probably put about a total of 20 mils in here. So I'm going to put 14 mils of the PET ether and 6 of the acetone. And then what I'm going to do, the second one is going to have PET ether and acetone, but 80-20 mixture. The third one will have PET ether and ethyl acetate in a 70-30. And then the last one, chamber 4, will be PET ether and ethanol in a mixture of 90-10. So what I'm going to do is just go ahead and fill these chambers up. They really need to sit for a while before you use them, just so that the solvent can equilibrate all throughout that chamber. Sometimes people will put a piece of filter paper behind it. I don't really think that's so necessary today, but you could put a small piece of filter paper behind that, and that will just suck up the liquid and kind of saturate the chamber as well. I'm not going to do that today, but it's certainly easy to do. Okay, chambers 1 through 4 are prepared. Again, the first chamber 1 is the petroleum ether and acetone 70-30. Chamber 2 is PET ether acetone 80-20. Chamber 3, PET ether ethyl acetate 70-30. And then chamber 4, PET ether ethanol 90-10. So I put 20 mils of each of those solvent mixtures in here. Always, and also just want to say, you don't have to use a binary mixture. You could certainly use a single solvent if it works, and there's no limit as to how many different solvents you mix together. I've used some that have been 4 different solvents mixed together. Ideally, you want those solvents to dissolve in each other, because that'll give you some more of the better separation. But these are the solvents, ones we could have done more. We're just going to do 4 to see, out of these 4, is there one that stands out amongst the rest as far as giving the best separation.